I want to do a couple examples now. I want to talk about significant figures, the number of digits you should present in your mathematical answers, how to round things off, and a couple examples of things. So first of all, let's talk about significant figures. All right. So here's the big idea. This has to do with how much you should round off your answers. Round off answers. Okay. So in order to do this, let's do an example. Here's what I'm going to do. I'm going to grab an ordinary ruler, and I'm going to measure the length of this same marker. And I'm going to measure it out. And what do we got? Oh, it is 4.5 inches long. This marker, 4.5 inches long. So I could say the marker, the length of the marker is 4.5 inches long. And then suppose as an exercise, now unit conversions is big, whether this is inches or a measure of length, and suppose I want it measured in something else. Suppose I want to convert it to centimeters. Okay, so there's the problem. There's the exercise. Convert to centimeters. That's a big deal. In the sciences we love the whole metric system just because it's very easy to convert from centimeters to meters to kilometers to megameters, whatever, this sort of thing. It's all just shifting things. So I want to do that. So what do? Well, I got to look up how many. I want to go from inches to centimeters. So I got to look up how many centimeters there are in an inch, and I look it up and I look it up and I look. And I find the factor in my book. I find that there are 2.54 centimeters equal to 1 inch. All right. Oh, it's a unit conversion. So what I do is I start out with a 4.5 inches, and then, all right, I need to, oh, jeepers. Now I need to either multiply it by 2.54 or divide it by 2.54. So how do I do that? And I don't know which one it is. Remember, I'm going to multiply by fraction. If I put the 2.54 in the bottom, then I'm dividing by 2.54. If I put it on the top, I'm multiplying by 2.54. Oh, I don't know. Let's say we put it on the bottom. 2.54 centimeters. I put 1 inch on the top, and then I look at the units. And I say, does this work? I've got inches times inches divided by... Oh, no, that doesn't work. The inches don't cancel out. This would be inches times inches divided by... No, that doesn't work. So putting it on the bottom is wrong. All right, so we're going to do this. So we're going to do 2.54 centimeters to 1. Oh, now that makes sense. Now I have an inches above and inches below. So So this means I need to multiply 4.5 inches times 2.54. So I go to my trusty calculator. We'll be getting to be good friends with our calculators, or good enemies with our calculators. We're going to see them a lot, whether you like it or not. Times 2.54. I type it into my calculator, and my calculator says 11.43, and then the units would be centimeters now. Centimeters, so that means that this marker, which is 4.5 inches long, is also 11.43 centimeters long. Except I'm not done. And here's why. Look at this. I measured 4.5 inches. That number has two significant figures, the 4 and the 5, and then that's it. Okay? So let's think about this. I guess, okay, let me get some space here. I need some space to talk about things. I have found that 4.5 inches equals, what did I convert? Equals 11.43 centimeters, but I'm not done. And here's why. In math, we use numbers differently than we do in science. And in science, there's more information. In science, first of all, you always got to stick a unit at the end of it. The answer to this question, how many centimeters, blah, 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 is not 11.43. It's 11.43 centimeters. We always have to stick the units on there. We say we don't want no naked numbers. A naked number is a number without units. That would be 11.43. No. The number has to be clothed. We have to stick the units on there. 11.43 cm, centimeters. And here's something else. 4.5... In math, 4.5 is the same thing as 4.50 or 4.500 or 4.5000. Mathematically, there's no difference between those things if I just stick a 0 at the end of it. But scientifically, there is a difference. Now you see, the truth is, this marker isn't exactly 4.5 inches long. It's just the best I could measure with this ruler, right here as it is. If I had a super accurate, heavy-duty micromonochrometer scientific measuring device, I could get more digits out of this. I don't know what it is. Maybe it's 4.5329 or something like this. Any quantity can always be measured more precisely, which means if I were to measure, I mean, there's always more digits here. To measure this exactly, you take, I don't know, an infinite number of digits. I was just doing a quick, ruler kind of glance at things. If I was really careful, maybe it's 4.52, or, and then I could put more and more digits on there. So whenever I'm measuring anything scientifically, I'm aware that I haven't measured it exactly. I'm close to it. 4.5. It's closer to 4.5 than it is to 4.6 or 4.4. That's the true statement. So I write 4.5. That means I have two digits of precision. If I wrote scientifically, if I said 4.50, mathematically that's the same number. That's the same number. Scientifically I've said something different. This is three digits, three significant figures. Significant figures. This, 4.5, now I've set it down to four significant figures. Significant figures. The 4, the 5, the 0, and the 0, and then this one has 5. Each time I'm telling you that, I'm giving you the same mathematical number, but I'm giving you a different scientific number because I'm telling you that my measurement is very, very precise. When I say 4.5, what I'm saying scientifically is that it's somewhere between 4.4 and 4.6. This is between 4.4 to 4.6, and I know it's somewhere in that range. It's not exactly 4.5. I can never measure anything exactly. I look at 4.50. Now I'm saying this is between 4.49 and 4.51. I've said, no, there really is a 0 there. That I know this down to three significant figures. Since this one has two figures, I'm saying basically I know this to within roughly 1%. Here I'm saying I know it to within roughly 1/10%. Here I know roughly to within 1/100%. This is between 4.499 and 4.501. This mathematically may be the same number as this, but this says I've measured it much, much, much more precisely. Okay, so the number of digits and sticking zeros at the end in science communicates useful things. So what does that mean? It means that I got 4.5 inches. It means I only know this number to within 1%. It could be anywhere between 4.4 and 4.6 is what that means. This number, as listed, has four significant figures. Your calculators will almost always give you way more figures than is actually meaningful. What this means is I only know this thing to the first two digits, and anything after the first two digits is junk. It's garbage. It's not telling me anything useful because I didn't measure it that precisely. I only measured it to the 1/10 of an inch sort of thing like that. I don't know nothing to the 100th of an inch or the 1,000th of an inch. It's a ruler, people. I did not get much more detail than that. So what this means is this is saying I know four significant figures out of that. In order to get 11.43, I'd have to have this one. But I didn't measure it that precise. I didn't measure it to the, tenths, hundredths. I didn't measure it to the thousandths of an inch. It's a ruler. So what that means is I'm not done. If I say, I have a marker that is 4.5 inches long, how many centimeters is this? The answer is not 11.43 centimeters. The answer is, rounding, 11 centimeters. Since 11.43, that's less than 11.5, we round it down, and so the answer is 11 centimeters. I didn't measure it any more precisely than that. 11, that has two significant figures. 4.5, that has two significant figures. The number of significant figures you have at the beginning should match the number of significant figures you have at the end, and so that's how it should work. And so if somebody gives me 11.43 centimeters, I will take a point off of that, because you're telling me your answer is accurate to within four digits, and it's not. I guarantee it's not 11. This is 4.5. Well, that means anywhere between 4.4 and 4.6. So over here, this could be, it could be 11.43. It could probably be 11.1. It could be 4. It could be 10.9. It could be within a range there. Scientifically, we never measure anything exactly. So we need to reflect that in our calculations. In the end, there are several things you got. So first of all, you got to get the right number, and you got to stick the right units on it, and then you got to round it off to the right number of places. How many places? Well, you figure out how many places did I have at the beginning, and then blah, 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 blah. Then when you get to the answer, you round that off to the same number of places you started out with. You can't end up more accurate than you started out with. If I'm only good to 1% here, your answer's only good to 1% there. So that's really, really, really important. Cool.